So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of identities. Now we will go through in this video an introduction to what is meant by an identity, and then we'll follow that up by going through some past exam questions. Now as always, if you're wanting to have an attempt at the questions relating to identities taken from the past papers, then all you need to do is just click on the link in the description below, which show you that you can have an attempt at the questions before watching this video as we go through the answers. Now an identity is an equation which is always true no matter what values are substituted. Now another way of looking at it is to say that algebraically both sides are equal and can be written the same way. Now obviously this applies to real numbers, so therefore the purest mathematicians may see an error in that statement, and basically real numbers are basically numbers that are legit and aren't imaginary. So for example, if we had on one side 2x plus 3x, that is going to be, now that symbol that you can see is what's usually represented as an identity, which is what we call a triple bar, and 2x plus 3x is equivalent to 5x. Now for whatever value that we make up for x, both sides are going to equal the same thing. So for example, if let's say x equals 3, then what we'd find is we'd have 2 times 3 plus 3 times 3, and if we work that out we've got 6 plus 9, which is 15, and that should be equal to, so then if I then do 5x, that's going to be 5 times 3, which is 15, and as you can see those sides are the same. And likewise, if I did, let's say x equals a negative number, just to prove a point, so let's say we had x equals minus 1, then here the left hand side would be minus 2 plus minus 3, and on the other side we would have 5 times minus 1. So minus 2 plus minus 3, well a plus and a minus become a minus, so that's going to be minus 5, and that's going to equal minus 5, and as you can see both sides are equal. Now more common examples of identities are this. So in a GCSE sort of exam, this is what you'd probably most likely see representing as an identity. So here we've got x minus y squared, and that's triple bar to x squared minus 2xy plus y squared. And basically what it's saying is that I could easily write this to look like this, and vice versa. I could make this look like that. So it's just a case of just showing a different way of representing the same thing. Now likewise, if I picked any value for x and any value for y, and I substitute it into both of the expressions on the left hand side and the right hand side, they should both equal, and that is therefore an identity. So here again the same thing applies for any value of x that I substitute into this left hand side. If I substituted the same x value into the right hand side, they both should equal. Now you might be thinking, oh, well, what type of questions could we get asked? So again, often you will get asked to prove an identity is true. So in other words, you want to show that both sides can be written the same, or you may get asked to compare coefficients to find the value of constants or letters on either side. And again, we'll go through some past exam questions in due course. But let me just explain to you what that basically means. So here, if I just get rid of all these markings. So if we look at this first example of to prove that identity is true, so what you would do is you would take, let's just take this first identity. Now typically speaking, when you see brackets you always think, right, let's expand it, because there's not really much I could do. So here with this particular question you've got two choices. Either you could expand and simplify the left hand side and show it equals the right hand side, or what you could do, and you will definitely want to do both, you could factorize the right hand side and show it's the same as the left hand side. So looking at this then, if I was to do such things, so if I was to take the first one, so here x minus y squared is x minus y and x minus y, and then if I expand the brackets I'm going to get x squared minus xy plus y squared, and then that simplified gives me x squared minus 2xy plus y squared, and as you can see, that equals that right hand side. And likewise, if I was to factorize it to get the same, so you always want to make a decision of what's easier to do. Is it easier to factorize or is it easier to expand and simplify? 9 out of 10 times, most likely always going to be expand the brackets and simplify. So likewise with this next one here, I've got two lots of x plus, that's going to be x squared plus 6x plus 9 plus 7. So expanding those brackets out, I get that, which ultimately equals 2x squared plus 12x plus 25, which again is the same as that right hand side. Now sometimes to try and get a better understanding about topics in maths, it's always worth just having a look at some common questions to try and translate what was basically said in terms of the teaching to try and put that into practice. Now we're going to go through about 13 past exam questions all related to identities, and if you're wanting to have a copy of these questions, all you need to do is just click on the link in the description and you'll have access to it, and you can either have an attempt at it if everything we've gone through in this video has made sense, or you can work with me as we go through each question. Now if you don't have an opportunity to print it, all you need to do is just simply pause the video, have a go at the question, and then unpause as we go through the answers. So looking at question 1, and hopefully you can see that clearly on your screen, it says that here we've got an identity of x plus a, and then we've got x plus 3a, and that's triple bar to x squared plus bx plus 75, and the question is asking us to work out the possible values of b. Now with these questions, they are in no particular order, so question 1 might be the most difficult out of all the questions that we do. So if the first question doesn't quite make much sense, do not worry, some of the other questions hopefully might make some. So let's have a look at this. So typically speaking, what you want to do whenever you see brackets is probably expand them. So if we then go on to expand this left hand side, then what we'll end up with is we'll end up with x squared plus 3ax plus ax plus 3a squared, and that's triple bar to x squared plus bx plus 75. Now if I just neaten that left hand side, then what I end up with is x squared plus 4ax plus 3a squared, and that is equal to x squared plus bx plus 75. Now what you want to do now is compare the coefficients. So basically what we should spot is that the number of x squareds is the same on both sides. The number of x's should be the same. You always want to kind of include the sign on the left as well. And running out of colours, and then the constant at the end. So these little things I've highlighted in each respective colour should be equal on both sides. So looking at this, what we notice is that, well, we know that 4a equals b, and we also know that 3a squared equals 75. So from this, there's nothing much I can do with 4a equals b because I don't know the values of a or b, but b is what I'm trying to find. So then if we look at this particular value here, then what we end up with is, to solve this for a, we get a squared equals 25. So therefore a is going to equal the square root of 25 plus minus, which is going to either be minus 5 or positive 5. Now the fact that it says two possible values should give you some indication that there are going to be two potential values. So here at this point, if you forget that plus minus, that little clue that is highlighted in the question should give you that little reminder that when you reverse a square and you've got square root, that your answer could be positive or negative. So using this then, so what we've then got is, so when a equals 5, then what we end up with is going to be, so if I've got, let me just write this out again, different colour, so if with 4a equals b, so when a equals 5, I'm going to end up with 20 equals b, so that's one value that I've got. Then when a equals minus 5, then I'll end up with, using 4a equals b, that's going to be minus 20 equals b. So there are my two values. So b can either equal plus or minus 20. So in that little answer box, it's just minus 20 or 20. And again, it doesn't really matter which order you write those two answers. Moving on to question 2, it says, which of these is a correct identity? So which is algebraically the same as the other side for all values of x? Well, it's definitely not going to be 6x triple bar 18, because if x equals 4, then this would be, let's say, and I've completely made x equals 4 up, so here that would be 24, and that's not equal to 18, so that's definitely not going to be the case. Again here, if x equals 4, then that's going to be 8 plus 1, which is 9, which is not equal 7, so that's not going to be a no-go as well. Here again, if x equals 4, we're going to end up with 28 plus 9, and does that equal 4? No, it doesn't, so that's incorrect. So the correct statement is going to be number 2. Now again, typically if you were asked between equations and identities always got that triple bar, but with these 4 options, all of them had that triple bar, so it's just a case of identifying the correct answer. Moving on to question 3, it says, here is an identity, and one that we've already seen. It says, use the identity to work out the value of 193 squared minus 7 squared. You must show you're working out. Now with this question, what you want to do is you want to spot the similarities between how this is written and how that is written. Now going from this to that in terms of what it looks like, here x has been replaced with 193 and y has been replaced with the number 7. So now what I'm going to do with those two variables and the values that I've worked out, I'm now going to substitute that into this expression here. So here what we've got is we're going to end up with 193 plus 7, and we're also going to multiply that by 193, take away 7. So this is going to equal 200, and that's going to multiply to give me 186. Now from this, what we then need to do is work this out. Now here the key thing, if this was non-calculator, you can either do long multiplication or you can simply work it out. Well here 100 times 186 is going to be 18600, and then if I multiply that by 2, it just makes the whole calculation that little bit easier. So here I'm going to end up with 0, 0, 6 times 2 is 12, carry the 1, 2 times 8 is 16, plus 1 is 17, and then 2 times 1 is 2, plus 1 is 3. So the answer then is going to be 37200. Next question B is not really related to an identity, it's more to do with difference of two squares. So let me just write that topic, but as it's part of that question linked, we'll go through it. So here, what do you have to square to get, so if I just create my double brackets, what do you have to square to get 100a squared? Well, 10 times 10 is 100, and a times a is a squared. What do you have to square to get 81? Well, that's going to be a 9. And what do you have to square to get b squared? Well, that's going to be a b. And one's a plus, one's a minus, and the order doesn't matter. So now let's have a look at question 4. So question 4 says, here is an identity, and we've got a bracket 3x minus 10, and then we've got the triple bar 21x equals 2b, and the question is asking us to work out the values of a and b. So again, what we want to do here is look at what can we do with either side. So we can't do anything with the right hand side, so but we can expand the brackets on the left hand side, so that then becomes 3ax minus 10a, and that's triple bar to 21x plus 2b. So then comparing the coefficients, so looking at this, we've got circle everything with an x on the left hand side, circle everything with an x on the right hand side, and we notice that we've got 3a equals 21, so a equals 7. For the next one, if we circle everything else that's left, so here we've got minus 10a, so everything without an x, so we've got minus 2a equals 2b. Now we know that a equals 7, so this is going to be minus 70 equals 2b, so therefore b equals minus 35, and so here I can write 7 and minus 35. It says work out the values of a and b in the identity. So again here we are comparing the coefficients. So again, not much I can do with the right hand side because there are no brackets and I can't really simplify any of that. So let's start by expanding this out here. So here I end up with 35x plus 40 plus 6x plus 3b, and that's equivalent to ax plus 13. Now if I just collect all my like terms together, I end up with 41x plus 3b plus 40, and again that's equivalent to ax plus 13. So then grouping and comparing the coefficients, I've got 41 equals a, so 41 equals a, so that one's done and dusted. Now for the constants, that's everything that hasn't got an x. So on the left hand side it's going to be all of this, and on the right hand side it's going to be that. So 3b plus 40 equals 13. Take the 40 over to the side, so I end up with 3b, and that's going to be equal to 27, and minus 27 rather, and so b equals minus 9, and there are my values of a and b. Moving on to question 6, again very similar, where we're comparing the coefficients. Hopefully you've kind of got the gist of this, so if you want to have an attempt, if you've not done so already, have a go at working this question and see if you get the same answer. So looking at this, not much I can do with the left hand side, that's kind of pretty much simplified, but I can expand this right hand side. So let me just start by writing everything out. So here we're going to end up with a. Now remember that this is a double bracket, so that's going to be, so this here is x minus b, x minus b. So a lot of students would write x squared minus b squared, which is completely and utterly wrong. So to always remember that when you've got a square outside a bracket, that it's double bracket still. So here then what we've got is we're going to end up with x squared minus 2bx plus b squared, and that's plus 3b. So then from this what we end up with is 2x squared minus 20x plus c, and then we end up with ax squared minus 2abx plus ab squared plus 3b. Now from this, what I then want to do is compare the coefficients. So here, looking at the coefficients of x squared, that these two things must be the same. So 2 must equal a, and so there is my a value. The next one is everything with an x. So everything with an x, so I've got minus 20 on this side, and that equals minus 2b, or 2ab rather. Now I know what a is because that's 2, so that then becomes minus 20 equals minus 4b, because again, let me just write that down as a equals 2. And so b is therefore going to equal positive 5. Now finally looking at the constants, so here I've got everything that hasn't got an x, I'm just going to highlight. Everything that hasn't got an x on the right hand side is all of this, which looks a complete utter mess. But here we've got c equals plus, let's get rid of that because I was looking at the wrong thing. So here I've got ab squared plus 3b. Now I know the values of a and b, so let me just go in and substitute that in. So c equals, and this is going to be 2 times 5 squared plus 3 times 5. So that becomes 50 plus 15. So c equals 65, which does stand out from the other values, but I can assure you is going to be correct. Then moving on to question 7, it says circle the identity. So here you can see that there's only one expression that's got a triple bracket, so the correct answer must be that fourth option. Now moving on to question 8, it says work out the values of a and b in the identity of 3ax plus 6 minus 4 bracket x plus b close bracket triple bar 11x plus 14. So again, the only thing I can do is work with the left hand side by expanding the bracket. So if I do that, I get 3ax plus 6 minus 4x, and it's going to be minus 4b. So you just need to be extra careful with the negative signs whenever you see them in front of a bracket. So then looking at comparing the coefficients, so if I circle everything with an x, well let's first of all start by neatening this up by just doing a bit of simple rearranging. And all I'm doing here is just swapping these two terms around, so just so that, and I've just seen that I've forgotten x there, so let me just change that for 3ax. And all I'm doing is just grouping the x's together and grouping the constants together on the left hand side. So from this, what I can then see is if I then circle everything with an x, or the coefficients of x on the left hand side, so that's going to be 3a minus 4, and that's going to equal 11. So from this I can then work out what a is, so 3a is going to equal 15, so therefore a equals 5. Then from this, what I can then do is look at the constants. So everything that hasn't got an x is 6 minus 4b, and that's equal to 14. So then from this, what I can then see is if I take the 6 over to this side, I end up with minus 4b is going to equal 14 take away 6, which is 8. And then from this, I can then do b equals minus 2. So here I've got b equals minus 2, and there is my final answer. Moving on to question 9, again, a very similar question. So here we're just looking at the value, find the values of a and b. Not much I can do with the left hand side, so what I'm going to do is I'm going to expand this right hand side. Now again, recognise that x minus 3 squared is x minus 3 x minus 3. Do not fall into the trap of just writing it as x squared minus 9, because that's definitely going to be wrong. So here we've got x squared plus ax plus b triple bar, and then we're going to end up with x squared plus, no, minus 6x plus 9 minus a. Then from this, what we then want to do is compare the coefficients. So there's no letters in front of the x squared, so that's going to be fine. So here we've got positive a equals minus 6. So a equals minus 6. No simplifying needed or solving. So a is just 6. And then on the left hand side, everything that hasn't got an x, or the constants, are going to be these two things here. So b equals 9 minus a. We know that a is minus 6, so that's going to be b equals 9 minus minus 6. So b equals, that turns into a plus, so that then becomes 15. So a equals minus 6 and b equals 15. The next question, B, again, doesn't really relate to identities. This relates to completing the square. And the smallest possible value, well, the smallest value that this could be is going to be 0. That's the smallest it could be. Even if x is a negative number, it's still going to be a whole positive. So the smallest number that could be is 0, and that's when x is 7. And so the smallest value that this could ever be is going to be 2. Moving on to question 10. Again, very, very similar to previous questions, so we can just go straight into it. So again, what we're looking at here is expanding this left-hand side. There are questions, believe me, that where you might have to expand both sides, but again, typically, just to save a bit of time, and for the low mark questions, it does tend to be only one side that you need to expand. So x plus a squared is x plus a x plus a. Now, again, I'm not going to the full expansion. With practice, you'll be able to do these in your head, but again, if you need to write it down, do so. As long as you get the right answer, that's all that counts. So here, what we've got then is we end up with x squared plus 2ax plus a squared minus 7, and that's x squared plus 10x plus b. So again, comparing the coefficients, no letters in front of the x squared, so that's fine. So here I've got 2a of the x's, and that's going to be equal to positive 10. So therefore, a is going to equal 5 again. Very common number for these questions. And then moving on to the constants, again, everything that hasn't got an x on the left hand side, which is all of this, and everything that hasn't got an x on the right hand side is going to be b. So here what we've got is got a squared minus 7 equals b. Now we know that a is 5, so that's going to be 25. Minus 7 equals b. So b therefore is going to equal 18. So here we've got a equals 5 and b equals 18. Moving on to the next question. Again, looking at this, we just expand this left hand side. So expanding that, we end up with 3ax squared, and it's going to be plus 3bx minus ax minus b, and that's equivalent to 12x squared minus 19x plus c. So here we've got letters on both sides, so let's have a look at what we've got here. So comparing the coefficients of x squared, or the number of x squareds, we notice that 3a has got to equal 12, so therefore a must equal 4. Then looking at the coefficients of x, so everything that's got x, so here we've got 3b and we've got minus a, so 3b minus a equals, and that's going to equal minus 19. So we know the value of a, which is 4, so 3b minus 4 equals minus 19. So then 3b equals minus 15. So therefore b equals minus 5. Then finally comparing the constants. So here I've got minus b, and on this side I've got positive c. Let me just do that again because I've completely obliterated that plus sign and got rid of the c. And it's this colour we were using. So plus c, and we've got minus b. So here minus b equals c. So minus 5 equals c. So c equals positive 5. And so a equals 4, b equals minus 5, and c equals positive 5. Then moving on to question 12, almost getting to the end. Here again, expanding the brackets on the right hand side this time. So x squared plus ax plus b, triple bar, and then we'll end up with x squared minus 10x plus 25 plus 7. So x squared plus ax plus b is x squared minus 10x, and that's going to be plus 32. So from this we can go straight into comparing the coefficients. So let's do a different colour though. So here we've got, is my pen working? Yes it is. So here we've got a equals minus 10 and b, positive b, equals 32. Then moving on to the last question, which I'm sure you'll be relieved at. It says, show that x plus 7 squared minus x minus 3 squared simplifies to give me this. Now, there's no really identity of this, but hopefully with the questions that we've done, you can see a common link. So looking at this, what we want to do is recognise that this is x plus 7, which is x squared plus 14x plus 49. And that's going to be minus, if I put this in brackets, here I've got, let's do a different colour, which, is it working? Oh, let's go for this one. So here I've got x minus 3, x minus 3. Now with this you do need to be careful with the brackets, with the negatives rather. So what I'm going to do is I'm going to swap this and put this in brackets. I've got x squared minus 6x plus 9. Now again, what you want to recognise here is that we do have a negative, so we could imagine there's a 1 there. So here what we've then got is we've got x squared plus 14x plus 49. Minus 1 times x squared is minus x squared. Then we've got minus 1 times minus 6 is positive 6x, and minus 1 times positive 9 is minus 9. Then from this, what we can then do is cancel the x squareds. So then I'm left with 14x plus 6x, which is 20x, and 49 take away 9 is positive 40. Then from this, we can then factorise with respect to 20, and we end up with what we wanted to show. The next question then says, hence or otherwise, work out 107, take away 97 squared. Now for this, what you want to do is you want to kind of spot links to what this looks like and what this looks like, all of this in entirety. So to use a, basically what you're substituting is a equals 100, because if you substituted a equals 100, this bracket would then become 107, and this bracket would therefore become 97. So all we then need to do is then substitute x equals 100 into this, in which we'd get the same answer. So here we'd have 20 times 100 plus 2, so it's going to be 20 times 102, and if we then work it out, well, that's going to be 1020 times 10 times by 2, so that's going to be 2040. Now an alternate method you could do is recognise that this is completing the square. So if we wrote it as completing the square, then that would be 107 and 97 and 107 and 97. One's a plus, one's a minus. If we work this out, that's going to be 204, and that's going to be multiplied by 10, which ultimately gives us the exact same answer as what we did if we used our answer in part A.